Hello students, welcome all of you in chemistry class today. In today's class we should discuss about chemical kinetics. Chemical kinetics is one of the most important topics in physical chemistry. You can expect questions both in competitive as well as a board level. It is in 1 mark, 2 marks or 3 marks like that. In the board level you can expect maximum 5 marks question also. Together there is no year in which there was no questions on chemical kinetics. Every year you should get questions on chemical kinetics from JEE, NET, etc. all exams from one or more than one questions. So let us discuss that first. Think of a reaction. A is the reactant that gives you the product. Now reactant decomposes to gives you product. So with time concentration of reactant decreases. Concentration of reactant decreases. On the contrary, as the reactant decomposes to gives you product, so concentration of the product should increases. The concentration of the reactant decreases. It is denoted by these terms. Differential coefficient is dA by dt. Minus dA is the decrease in concentration of A with time. Now it is represented as the rate of the reaction. Now what is the unit of concentration? Moles per liter. Time, if I take it to be second, so unit of rate should be moles per liter per second. On the other hand, as concentration of the product increases, in this case B is the product, so the rate can be expressed in terms of product also. R is equal to dB by dt. As B is the product, its concentration increases. It's written as moles per liter per second. In this case, stoichiometric coefficient of A and B both are 1. But if the reaction is represented this way, suppose a reaction is given as A gives you 2B. Means for every 1 mole of A, decomposition to gives you 2 moles of B. So in this case, if I write minus dA by dt equal to dB by dt, then it is wrong. So minus dA by dt never equals to dB by dt. In this case, if I want to write an equal sign between them, how to do that? See, for every 1 mole of decomposition of A gives you 2 moles of B. So twice of decomposition of A, if I write it this way, minus 2 dA by dt equals to dB by dt. That means for 2 moles of decomposition of A, 2 moles of decomposition of A produce 1 mole of B. As a result, in this case, before the constant change in concentration of the A, multiply by 2 to make it equal to B. So it is minus 2 into dA by dt is equal to dB by dt, or I can write this way, minus dA by dt equals to 1 by 2 dB by dt. Now let us look at the more example of it. Suppose in this case it is given as 3A gives you 2B. In a nutshell, in order to express the rate of the reaction in a competitive exam, what you should do, rate is equal to, for reactant it will be negative because its concentration decreases. For product it will be positive because its concentration increases. Stoichiometric coefficient will be 1 by that value. In this case, stoichiometric coefficient here is 3, here is 2. So in this case, rate is equal to minus 1 by 3 dA by dt equals to 1 by 2, because the stoichiometric coefficient for A and B are 3 and 2 respectively. Means for every 3 moles of decomposition of A produces 2 moles of B. So it is minus 1 by third dA by dt is equal to 1 by 2 dB by dt. Look at the reaction. 2NH3 gives you N2 plus 3H2. If I want, because in this case more than one product is formed over here, so it will be minus 1 by 2 dNH3 by dt equals to 1 by 1 dN2 by dt equals to 1 by 3 dH2 by dt. This is the way how I can express rate in terms of change in concentration of the reactant and product. Its unit should be, concentration is moles per liter, so its unit should be moles per liter per second. This is the concept of expressing rate of the reaction in terms of change in concentration of the reactant and product. Now, in chemical kinetics, we should come across this word. One of them is called molecularity and order. Molecularity. What is molecularity? Molecularity defined as number of molecules which takes part in a reaction. Molecularity means number of molecules takes part in a reaction. Molecularity always have integral values. In this case 2NH3 gives you N2 plus 3H2. So what is the sum total of the coefficient of the reactant molecule? 2. In this case molecularity is 2. On the other hand, if you think of the case PCl5 decomposes to PCl3 plus Cl2, in this case number of molecule is 1, so molecularity will be 1. So molecularity in the overall reaction, total number of molecules which takes part in the reaction, that is reactant molecule, gives the molecularity of the reaction. It is a theoretical concept. Looking at the reaction, I can say what will be the molecularity of the reaction. But order is something different. Let us explain that. First of all, chemical reactions are of two kinds. One of them is called elementary reaction. Other is the case of complex reaction. Elementary reactions are those reactions which takes place in one step. Okay, suppose in this case any reactions which takes place in one step, suppose will be an elementary reaction. A is the reactant, B is the product. If A decomposes to gives you B directly, it is an elementary reaction. But on the other hand, there are some reactions which takes place in more than one steps. Complex reactions are those reactions takes place in more than one step. The reaction which takes place in more than one step, there is a step that is called rate determining step. That is the slowest step. In the slowest step, number of molecule takes part gives the order of the reaction. I will go in detail about it. Suppose look at here, 2H2O2 gives you 2H2O plus O2. So molecularity of the reaction is 2. But if they ask you the order of the reaction, the reaction takes place in 2 steps, which is provided to you. H2O2 gives you H2O plus O, then again H2O2 gives you H2O plus H2O2 gives you H2O plus O, H2O2 plus O gives you H2O plus O2, and it is the slowest step, it is stated to you. So it is the step 1, first step, it is step 2, that is second step. If you add these 2 steps, what we are getting, H2O2 plus H2O2 plus O gives you 2H2O plus O2 plus O. O get cancels, so gives you 2H2O2, gives you 2H2O plus O2. Okay, so in this case, if they ask you what will be the order of the reaction, look at here, underlining it, that is the step 1. In the step 1, how many molecules of H2O2 takes part? 1 molecule. Though molecularity is 2, so order of the reaction will be 1. Okay, in this case, the decomposition of H2O2 to H2O to O2 is a first order reaction. So in this reaction, I should write molecularity 2, that's the overall 2 molecules takes part, but in the determining step only 1 H2O2 takes part, so order of the reaction is 1. Molecularity is 2 but order is 1. Now let us discuss one more case. Order of a reaction is experimental property. So hence, looking at the reaction, I can state about its order. Order of a reaction can be positive, negative, 0, or fraction also. So let us look at the reaction. A2 plus B2 gives you 2AB. It is the overall reaction. The steps takes place in the reaction are as follows. Step 1, A2, reversible sign 2A. That is first step. It is known as the K equilibrium because it is a reversible case. Second step, step 2, A plus B2 gives you AB plus B. This is slowest step. Third step, step 3, A plus B gives you AB. If I add these 3 steps, A2, step 1 plus step 2 plus step 3 gives the overall reaction, that is A2 plus B2 is 2AB. On adding these two, I am getting this result, A2 plus B2 2AB, what I am getting. Now what I want to tell you, A2 plus B2 plus 2AB, this I will get if I add all this case. Okay, next what I want to tell you, if is the overall. Now for this case, what will be the order of the reaction? Let us go to the next page. Suppose in this case I have written so A2 plus B2 gives you 2AB. A2 gives you 2A. This I have written as K equilibrium. Then I have written A plus B2 gives you AB plus B. That is a rate determining step or slowest step. Slowest step sometimes known as RDS, a rate determining step also. Then A plus B gives you AB. This is the overall reaction. Now it is the slowest step. The relation between rate with concentration of the species can be written this way. Rate is equal to K. K is called rate constant into slowest step. It is A to the power 1 into B2 to the power 1. A to the power 1 into B2 to the power 1. In the slowest step, number of A is a part, B2 is a part. So rate is equal to K. K is called rate constant. A to the power 1. A is the atomic species. B2 to the power 1. But in the overall reaction, there is no A. It is A2. So in this case, I have what to do? Express A in terms of A2. Because the A is not stable one, so I have to express A in terms of A2. A is the transient species. In order to express the rate of the reaction, I have to express it in terms of the stable species A2, B2, etc. Overall species, you see, rate of the reaction always expressed in terms of the concentration of the reactant, not in the transition species which is formed, which is unstable. To do that, what I have to do? K equilibrium A square by A2. So A square is equal to, hence A square is equal to K equilibrium into A2. A is equal to K equilibrium to the power half into A2 to the power half. Instead of writing A, I am writing as K equilibrium to the power half, A2 to the power half. Express it. Rate is equal to K into K equilibrium to the power half, A2 to the power half into B2 to the power 1. This whole thing is a constant. K into K equilibrium to the power half is a constant. It is the rate. Order is the sum total of stoichiometric coefficient in the rate determining step. In this case it is half, in this case it is 1. So order of the reaction one plus half, that is 3 by 2, that is 1.5. So in this case order I found out to be fractional. I told you order can be positive, negative, 0 or fraction also. So in this particular case molecularity is 2, order is what? 1.5 or 3 by 2. Because rate of the reaction, when I express rate in the slowest step, A is not the stable species. A have to be expressed in terms of A2. That I have done it. Then replace it into the equations. I am getting A2 to the power 1 and A2 to the power half and B2 to the power 1 gives you the order of the reaction 3 by 2 and molecularity is 2. Is it clear to everybody? Then, so in this case A2 plus B2 2AB molecularity to order 3 by 2. Suppose we have an equations MA plus NB gives you product. A and B are the reactant species, stable species, not the transition species. In this case, molecularity will be what? M plus N. And in the sum, it is a complex reaction takes place in a number of steps. In this equation, they have mentioned slowest step as this. Slowest step should be provided to you. So, order of the reaction should be P plus Q. Sum total of the stoichiometric coefficient in the slowest step gives the order of the reaction. Sum total of stoichiometric coefficient slowest step give order. It can be positive, negative, zero or fraction also. Now let us come to the another part of it. Suppose for a zero order reaction, what will be the expression? Before going to zero order, first order, second order, I want to mention one more thing to you, that the case of rate constant. Now rate of a reaction depend upon following factors. The factors on which a rate of the reaction depend are concentration in liquid state, pressure in gaseous state, then specific surface area, temperature. In some cases you can say catalyst also. Now let us discuss on all these factors clearly to you. Now a reactant doesn't gives you the product directly. According to theory, collision theory, what happened? A reactant molecule collide with one another, and the molecules having energy equal or greater than threshold energy is capable of forming product. So if I express this way, suppose it is the energy. It is the progress of reaction. We have got two curves like that. It is the ER, it is the energy of the reactant, it is the energy of the product. Reactant doesn't see the energy of the product is more than that of the reactant. So there is a term that is called del H. Del H is equal to EP minus ER in thermodynamic term. As energy of the product is more than that of the reactant, so the system, when reactant converted to product, it is absorbs energy from the surrounding. It's an example of endothermic reaction. In this case, this part is called EX. This is called threshold energy. So the energy required for the reactant molecule to give product, so reactant molecule has to acquire this energy to get it into product. So activation energy for reactant, equal to EX minus ER. Reactant molecule on itself having some energy, because the E stands for internal energy. In thermodynamics we have learnt whether you apply pressure or not, temperature or not, that doesn't matter. Molecule itself possesses some energy, depend upon its mass, bond length, etc., etc. So many factors. This energy is called internal energy. It has been excited to EX to get into the reaction. So Ex minus Er is the excess energy reactant molecule has to acquire. So activation energy for product will be what? For product will be Ex minus Ep. As Ex minus Er is greater than Ex minus Ep, so we can say what? That in this case reactant is more stable than that of the product because its energy is less. So the chance of forming product is less. Now think of another case. It is Er, it is Ep, it is threshold energy. In this case Ep less than Er. So in this case when the reactant converted to product, it gives energy to surrounding. Hence exothermic reaction. Former one was endothermic, the later one is the exothermic. So in this case activation energy for the when the reactant converted to product as its energy is less, so the formation of the reactant to product is more likely, because everything want to be in the form that is more stable, having less energy. As energy of the product is less than a reactant, so it has a more chance of forming product. Now what I want to tell you, I want to express the rate of the reaction in terms of concentration in case of liquid, product in case of gas, etc., etc. Now what is collision theory states? Collision theory states if we increase the concentration of the reactant molecule more, so more will be the collision between the reactant molecule, more they passes the energy barrier, so faster will be the reaction. So rate of the reaction proportional to concentration of the reactant, proportional to concentration of reactant. This is equated with a constant that is called rate constant. Rate has an unit of change in concentration by time, but rate constants has different unit for different reactions. Now we'll express the what is the rate constant, unit of rate constant for different order reaction, 0, first, second, and overall, how to express that. So rate proportional to concentration of the reactant. If I want to make them equal, I should write rate is equal to K into concentration. If I increase concentration, more will be the collision, more will be its rate, more it passes the threshold energy, more will be the rate of the reaction. So with increase in concentration, rate of the reaction increases. For liquids, in case of gas, with increase in pressure, more will be the collision, but because more number of molecules in the gaseous system, more will be the collision between them, more the chance of passing the energy barrier, faster will be the reaction. So with concentration, rate increases. In case of liquid, in case of gas, with pressure, collision increases, rate increases. Now it is obvious, if we increase temperature, more will be the collision between the molecules, they passes the energy barrier more readily, so rate increases. In the former case, with change in concentration, the pressure, only rate increases but rate constant doesn't change. But in this case, with increase in temperature, rate as well as rate constant increases with increase in temperature. There is one more interesting factor, that is the case of catalyst. Suppose it is the energy of the reactant, it is the product, it is uncatalyzed process. In case of catalyst, what happened? Catalyst cannot change the energy of the reactant and product. Catalyst provide an alternative path, that is decreases the threshold energy. As it is decreases the threshold energy, more molecules can pass the barrier, so rate of the reaction increases. So catalyst do what? Catalyst lower the threshold energy. Hence, rate increases. This is a case of positive catalyst. If you take a negative catalyst, what it does? It raises the activation energy. So less molecule will pass the barrier. So negative catalyst decreases rate of reaction. Okay, so in a nutshell, what we have decided so far, I told you rate of the reaction depend on 4 factors. What are that? Concentration in liquids, pressure in case of gas. With increase in pressure or concentration, why the rate increases? Because according to collision theory, more the number of collision between the molecules, more they passes the energy barrier, that is the threshold energy. So faster will be the reaction. As a result, increasing concentration for liquid, pressure in case of gas, rate increases. Next factor is temperature. What temperature does? With increasing temperature, energy of the molecule increases, because they absorb heat from the surrounding, and as a result its energy increases, so more readily they pass the energy barrier, so the rate increases. Catalyst, positive catalyst do what? They lower the activation energy, so makes the reaction faster. After that, we have done a negative catalyst. What is negative catalyst does? Negative catalyst lowers the activation energy. Positive catalyst lower the activation energy, so more molecules can pass the barrier, so makes the reaction faster. Negative catalyst raises the activation energy. Negative catalyst raises the activation energy. See, negative catalyst is this part. I have shown in the graph. Negative catalyst is this part. You see, it is for negative catalyst. It raises the activation energy, so makes the reaction slower. And this is for positive catalyst. It lowers the activation energy and makes the reaction faster. More molecules can pass the barrier, but catalyst itself cannot change the energy of the reactant and product. Let us up to this for today's class. Next class I should upload more videos on the remaining part of chemical kinetics. Thank you.